Good morning and welcome to the video for Monday, January the 4th. Hope you all have had a good Christmas break and are looking forward to being back in building here in about a week and a half. Looking forward to seeing all of you again. In the meantime, we are going to be doing videos, so there will be no live stream until I am back in building with the main portion of the class. So for those of you that are not used to that, I apologize. What we are going to do is a short video that talks through the lesson. If you need to pause the video, go ahead and do that. Go rewind it if you need to see something a second time. Today's lesson should be pretty easy. We're going to be doing something similar to what we've done before in our daily math book, but we are going to be doing an entire lesson working with it. So we are going to be working with exponents today, and we are going to be working with something that is a base that's different than 10. Before we've done powers of 10, so we would have like 10 to the second power would be 10 squared, or a 1 with 2 zeros at the end. Or we might do like 10 to the seventh power, which would be a 1 with 7 zeros after it, which actually I think I just gave you the answer to one of the homework problems on accident. Would not be the first time that I've done that. You'll notice that I have a thing that has all the homework. So if you are comfortable with what we're doing and you want to jump to the homework, I don't recommend you do that, but if you want to, you have that available. So for number one, we are going to use 3 as a repeated factor. We're going to multiply 3 times 3 times 3 times 3. So we are going to use that as a factor 4 times. The base is going to be 3. The exponent is the number of times that we're multiplying 3 together. That would be 4. Now, the answer for this would be the answer to 3 times 3 times 3 times 3. So 3 times 3 gives us 9. 9 times 3 gives us 27. Think about what the answer to 27 times 3 is. It should be 81. Because we can cheat and break this apart. Oh, okay. So I don't think I've ever explained this to any of the other classes. There's a trick that you can do to figure out the answer. So we could break this apart. So we could actually do 3 times 3. And 3 times 3, we could get 9 times 9 to get 81. So that is a trick that will work if you have... it's probably better if we're working with an even number. You can kind of do it that way. Like for instance, 4 would probably be, fourth exponent would probably be pretty good to do that with. So let's see, numbers A. So we're working with 7. Think about how many times we are multiplying 7 to itself. And that would be the number that is going to be the, that would go down here. The base is going to be the number itself. And so if I write the base with the exponent, I would write a 7, and then I would have a 5 up here. I would put it on the line, but it's really hard for me to write with the mouse, as some of you may remember. And I want to make sure that I do that correctly. So we are going to, for letter B, have 2 different bases. And so we have 1 for 6s, and we have 1 for 8s. So think about the number of times that we multiply 6 by itself. And that's going to be the answer for this one. And the number of times we multiply 8 to itself is going to be this one. And so we can actually end up with a problem that has multiple exponents. And then we may be asked to find the final answer of all of our multiplication. But for the most part, for right now, we may only end up with something like this for the answer. So we used 6 twice. We used 8 3 times. So 6 to the second power, or 6 squared, times 8 cubed, or 8 to the third power. And then that would be our answer, instead of trying to find the answer to both steps. I'm going to skip this. We know how to do that. This is, again, we're doing 10 times 10 times 10. And the answer to that would be, we could go ahead and break this out, 100 times 10. I did a shortcut when I was teaching you guys how to do this in third grade, where we could just put a 1 and then put that number of zeros at the end, because that ends up giving us the correct answer. We will have some problems where they give us a number and then they give us the base. And so we already did this before, but we did 3 to the second power. So 3 times 3 would give us 9. 3 to the third power would give us 3 times 3 times 3, which would be the same thing as 9 times 3, which would give us 27. And then we would keep going. So when we have some problems for this later on, especially for the homework, they want you to go ahead and start with the base number. I think there's one for working with 12s. And then they want you to multiply 12 times 12 and figure out if that gets you there. If it doesn't, actually, I think it does it with 7s as well. And so for this one, we would have 3 times 3 times 3 times 3, which would get us all the way to 81. And so this would be 3 to the fourth power, or it would look like this if I didn't cover it up. So this one. All right, so let's look at number 2. Is 5 to the second power equal to 2 to the fifth power? So think about what the answer to 5 times 5 is, and then think about if you could multiply it by 2's to get to that number. Okay, so assuming that you did that, we are looking at 25 on this side. If I am always working with 2's, I'm going to do 2 times 2, and then I'm going to double. And so I'm going to keep doubling even numbers. So can I get to an odd number if I start with an even number and keep doubling it or multiplying it by an even number? So in third grade, we learned what our patterns were. If we're multiplying an even number by anything, we will always get an even number. So just remembering that part, we can never get to 25 if we are multiplying by 2's. At least not using whole numbers. If I did like 12 and a half times 2, then yeah, we could get to 25, but that's not what we're doing. And then example 2, how would we do that with division? You could try doing 25 divided by 2, and if that worked out evenly, then that would have been successful, but that doesn't work. All right, so let's go to our next page. If I tell you to turn the page, I apologize. Everything's a page turn for me. So we are on the top of Sharon's show now. So we want to do 2 to the fourth power. So we have 2 more 2's it looks like we need to write in here. And then we need to find the actual value. So we would do 2 times 2 to get 4, times 2, doubling it, gets us to 8. Double 8, that gets us to 16. All right, so now we have some slightly more difficult ones. So 7 to the fourth power. We may eventually have to give the value for that, but at least for right now, we're not doing that. We have 5 to the 1, 2, 3, 4, fifth power. And then this time we have 2. So we would write those with a time sign in between. And so we would do 3 to the whatever power times 4 to the whatever power. And so if we go ahead and plug those in, again, I'm assuming that you probably know how to do this. If you need a few extra moments, you can pause the video and do that for yourself. Now for these, I will ask you to go ahead and pause the video. So I want you to look at number 5, number 6, and number 7, and we want to figure out what the answer for all 3 of those are if we write it out without the exponent. So 20 to the second power would be 20 times 20. This one would be 82 times 1, and this would be 3 times 3 times 3 times 3 times 3. We already got the answer to 3 times 3 to the fourth power, so we could go ahead and keep going from there. So go ahead and pause the video and work on those, and then I'll talk you through what we need to do for number 8 after that. All right. So assuming that you did that, our first one, we are looking at 20 times 20. That would give us a 4 with 2 zeros at the end. And so that would give us 400. This one would be 82, or the number itself. And then this one would be 81 times 3, which would be 243. So we could do 1 times 3 and then 80 times 3 to get the 240 part, and then add those together. Number 8, write 32 as a number with an exponent by using 2 as the base. So what we did on the other page, and what I think they also did at the top of this page, nope, it was the other page. So let's go back a page real quick where we did this. We wanted to figure out what each of our exponents were worth. So 3 to the first power would just be 3. 3 to the second power would do 3 times 3 to get 9. 3 to the third power, we got this, and then so forth. So if we're doing that with 2's, we want to figure out how many times we can multiply 2 by itself to get to 32. So one of the things that you could do is actually do 32 divided by 2, and then keep dividing until we get back to 2. But we could also do it the other way, and we could just multiply and keep doubling. So think about how many times we need to do that. And when you're ready, go ahead and hit play again. I'm assuming that most people probably got this while I was talking. So if I do 2 times 2, I get 4. 4 times 2 gives us 8. So 4, oops, there we go, 4, 8, 16, 32. So it's going to be 2 to the 5th power. All right, the next one. How many times do we need to multiply 5 by itself? So 5, and then 5 times 5 would give us 25. And then what would the answer to 25 times 5 be? So think about that for a second. That should give us our correct answer. So 25 times 5 gives us 25 here. Carry a 2, 5 times 2 plus 2 gives us 12, and so that would give us 125. So it'd be 5 to the 3rd power. This one, if I start and end at the same number, it's going to be the first exponent. And then think about how many times you can multiply 30 times itself to get 900. So 30 times 1 would be 30. 30 times 30 would be what number? And that should give us 900. So it would be 30 to the 2nd power. All right, number 12. We want to find the values of 4 to the 1st, 2nd, 3rd, 4th, and 5th. And then we want to look for a pattern that can help us figure out what the answer for 4 to the 6th power should be. I believe that is a 6. If it's an 8, I apologize, but it looks like a 6 on my tiny little screen. But they make these so small. It doesn't look like it's even on the top and bottom, so that's why I'm guessing it's a 6. You guys are probably in your book looking at like, hey, Mr. Parks, this is really easy to figure out. It's really small on my screen and hard to read. So what I would do is to go ahead and make the list. So we will see something similar to that on this next page. So like 4 to the 1st power would be 4. 4 to the 2nd power would be 4 times 4, which would be 16. So we could do something similar to that. So if you want to use that to help you. So we are going to do 4 and then 16 and then 64 and then 256 and then 1024. Yeah, 1024. So the pattern actually is was we're taking the number and multiplying it by 4. There isn't anything special. I will tell you, if you know about things related to computers, that these are all numbers that you would hit as multiples of twos. So when we're working with um, I mentioned this in class one day. So one of the days that I just went on a rant about some nonsense on the board, and kind of drew up as you have different bytes and everything. And so you can go ahead. This would be 1024 would actually be the proper size of a megabyte. Although now with hard drives and so forth, they and actually 1024 would also, well, it'd be slightly different, because we would get up to a larger amount. Um, but this would be also the number of, um, for a gigabyte would be 1024 megabytes instead of 1000, which is what they do for hard drives. I think that's what I was rambling about one day. All right. So we would go ahead and predict the ones digit by doing this number times 4. And so that should give us a 6 in that. So the ones digit would be a 6 because we would have 16 when we do, oops, 1024 times 4, we would get a 6 there. And so that would be what we were looking for the answer for that. Number 13, let's figure out which expressions are equal to 32. So if I do 2 times 2, that gives me 4, oops, 4, 8, 16, 32. So that first one would work. What about 8 to the 4th power? So think about that. So 8 times 8 times 8 times 8. Would that give us 32, or would that give us something different? That should be something different because 8 times 8 by itself would be 64, which would take us past that. If we did 8 times 4, that would get us there. For this one, is speaking of 8 times 4, if I do 2, did it the wrong direction again. I hate looking at myself in a mirror. 2 times 2 times 2 would give us 8. So this one would work. And then we could go ahead and group like this and do 8 times 4, and that one would also work. All right, so for this one, we just have a chart. This is for the amount of time, and then we want to use our exponent. So we would basically just be filling in this chart. We're going to use a doubling pattern. So this should be pretty easy. So I'll let you go ahead and pause the video. We'll go ahead and do this part real quick, and we'll talk about one of the questions here. And then we'll go ahead and go forward and look at the homework. So assuming that you're done with this, let's go ahead and finish filling this in. We would get 2 times 2 times 2. 4 times 2 gives us 8. And then we have the 4th power, 5th power, 6th power here. And then we're just going to write in a bunch of 2's to fill in all of this stuff. And then that would go from 16 times 2 gives us 32. 32 times 2 gives us 64. 64 times 2 gives us 128. And then we're counting 20 minutes at a time in this. I didn't mention that. It was something that you guys could read. So I'm not going to read it to you. But yeah, the idea was that after 20 minutes, then we split. And so this would take us from 120 minutes up to 140. And then if we were to keep going, which power of 2 shows the number of cells after 3 hours? So we are at 2 hours when we get here. So we would need 2 more here to get to 180 minutes. So we would have 2 to the 9th power. So I want you to figure out how many cells we would have if we go ahead and continue that doubling pattern. So go ahead and pause the video if you need to. So from here, we would go from 128 up to 256. And then we would go from 256 to 512, which would be our answer for this part. All right, let's take a look at our homework. So for tonight, we are doing 2 through 11. I did give you an answer to that. I thought I did. So again, for number 7 and number 8, you are going to start by doing 12 as the base for this one. So you can do 12 times 12, figure out if that gets you to 144. And then if that does, then that would be the second power. We're going to do something similar. We're going to do 7 times 7. If that doesn't get us to 343, then we need to take that answer that we get for 7 times 7, multiply it by 7, and we're just going to keep repeating that until we get to 343. And the number of times we multiply 7 is going to be what our exponent is going to be. Oh, that's not cool. I did the same page twice. Let me see if I can fix that real quick. Actually, I have to find it. Oops. Sorry about that. All right, there we go. Crisis averted. All right, so on the back, we are going to be looking at all 6 problems. So number 1 on the back, okay, that should be easy enough. Number 2, number of gallons of water in a tank is equal to, I can't even read what that is. Oh, it's supposed to be 8 to the 3rd power, it looks like. So think about what that is. We've already kind of worked with that. Let's see, number 3, we're working with ratios. Number 4, we want percentage. So we want to change that to parts out of 100 to be able to figure that out. Number 5, how many milliliters? So we are going from a larger unit to milliliters. So if you remember correctly, we would be multiplying. And we would go ahead and start with liters, and then we go to deciliters, then centiliters, then milliliters. So that can help you figure that out. And then we have the formula here. So we have our distance is equal to the rate, which is 50 miles per hour, times the amount of time that we travel. So we can do 50 times 4.5 to find the answer for that. So that concludes everything I want to go over for today. If you have any questions, please feel free to ask in Google Classroom. You can send me an email. Again, I'm asking for all of this to be turned in once we get back to school. If you are an online student, you can go ahead and submit it to me in the normal way. And if you have any questions, you can send me those that way as well. So either with the Google form, or you can send me an email, or have a parent send me a text with your pictures to go ahead and turn in that homework. Hope you have a great day, and I will see you tomorrow.